Okay, well, let's go through the mechanism and the products here. And you know what's wrong?
Well, I'm just trying to, because this is a carbon, this is a carbon, this is a carbon, and then this is supposed to be a carbon, but then I'm putting it there, so that's the carbon.
Okay, all right, good. So, so you're right, something is going a little bit wrong there, but at least you're noticing that. A lot of people kind of, I think we talked last time, a lot of people kind of just use the hope for the best strategy. They just draw something that feels good. Yeah. Well, we have to make sure this is right. Okay, by the way, remember there should be a positive charge on this magnesium. It's always important to show all the charges. Okay, so we put this in. Now, it's good that you're using numbering here, and we don't need to number these other carbons in the ring, but these two carbons here are important, just for reference, not the IUPAC. Now, I think that this might be a little bit easier again if you start with the compound at the tail. Somehow it's more intuitive.
No, I did the other way. I thought that that's what you said. Okay.
Because in a sense, the electrons are coming from the tail. Right? So it's a little more intuitive to start with the compound at the tail of the arrow. Mm-hmm. Okay, so let me talk you through how I would do that. So I'm going to start by just redrawing this compound at the tail. Space. And I'm going to keep putting in the numbers. So it's good that you're using the numbers. That's a key step. Now, who is the number 4 attached to?
4 is attached to the second carbon.
Go ahead and draw that for me. Fine. And don't worry about where you put the number 2 carbon. Just put it someplace that's attached to the number 4. If our initial picture doesn't look pretty enough, we can always redraw it. The important thing the first time around is just to get the bonds in the right place. Now you work it out. Okay, good. And now we ask, who's the number 2 attached to? Well, we can see the number 2 is attached to the number 1. It's attached by a sigma bond to the oxygen. It lost the pi bond. And it's attached to the number 3. It might help to even just use your finger to trace out who is this guy attached to over here.
What did you say you start with the what?
It's probably best when you're drawing the product to start by drawing the part that was at the starting material that was at the tail of the arrow originally. Do you see why that's kind of just intuitive? Because in a way, this is kind of the start of the reaction. The electrons are starting from here and going to here, so to speak, anyway. So I think it's most intuitive to think of this, in a sense, as the start of the reaction. So I think people have more intuition for going through it this way. But the most important point is, again, just using your finger to carefully ask which atom am I focusing on and who's he connected to. So the thing that was messing you up was the connection between the 4 and the 2. And the problem was that you were trying to draw them both as the same atom. I think we saw that problem when we met yesterday as well. You were tempted to think that they were the same atom. Well, instead we should draw the number 4 and then draw a bond to the number 2. I guess that was the one step that you were leaving out. If two things are connected, there should be a bond between them. That seems like common sense, but when people are in the middle of a problem, it's easy to get confused. If you know that two things are connected, you got to draw a bond between them. So we have to draw this bond between the 4 and the 2. All right, and then you fix the charges. The 4 has become neutral, and the oxygen has become negative. We might as well put the counter ion over here. We talked last time about how the magnesium and the bromine don't participate at all. They're just spectator ions. Good. And you drew the arrow towards the hydrogen. Good. Okay. All right. So again, the moral here was that it's somewhat tricky and time-consuming to get the right products from a Grignard. Why is it tricky? Well, because notice we're making new carbon-carbon bonds, so you can see that the products end up being much more complicated than the starting materials. We haven't really seen molecules that were this complicated in the past. So you have to take your time, make sure that you're getting all the carbons in the right place over there. So again, the trick that we saw here that was helpful is start maybe by redrawing the compound that was at the tail and leave plenty of space around it to put in the new thing that it's going to be attached to. I think we talked last time about drawing a big picture with plenty of space as well. Okay. And then you kind of just carefully go through atom by atom and just point at them with your finger and ask what is each thing attached to. Okay, so let's try to use all those techniques here. Because we really have to have this mastered before we can do synthesis. This is all stuff that has to be part of doing a synthesis problem. So let's take our time and use the techniques that we were just talking about for this problem. right, we got it. Very good. All right, so again, we started with the compound that was at the tail, leaving ourselves plenty of room. Probably the only carbons you really need to number here are this one and this one. Those are the only ones that are participating, so that's what you did. So here's our number 1 carbon. Who's the number 1 forming a bond with? The number 2. Now the classic mistake is to try to make this the number 2 as well. This is not the number 2. This has to be bonded to the number 2 separately. And then who's the number 2 bonded to? Well, the number 2 is part of a ring. And the number 2 is also going to be single bonded to the oxygen. And originally we'll have this charge. Okay, so that was your intermediate, and then you protonated.